Good morning, everybody. Welcome back. We're going to finish chapter 4 today. Chapter 4, section 5 and 6. Oops. To begin with, tell me the rational zeros yeah, I'll just leave it at that. Find me the rational zeros. And oh yeah, the number of possible positive, negative, or rational, but special, we'll call them specials. So with this question, tell me all the possible solutions and then how many positives, negatives, or specials we're going to have. Remember rational zeros. Or P over Q, I should say, not P of X, Q of X. P over Q. What's P? No, actually for yeah, I missed it. It's the constant, so it's 6. And the Q is the leading coefficient, so it's 1. So the next thing we do, we find the factors of 6. 1, 2, 3, and 6. Since we only have one denominator. So now we take each one of them. So it's plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, and plus or minus 6 over 1. If we had another denominator, we'd do that whole list again. So our possible rational zeros, 1 divided by 1 is 1, 2 divided by 1 is 2, 3 divided by 1 is 3, and 6 divided by 1 is 6. So those are our possible answers. Then to find our factors, if we're doing that, we take each one of these, start with positive 1, then negative 1, positive 2, negative 2, until we get a remainder of 0. So our polynomial was x cubed plus 2x squared minus 5x minus 6. This is our P, this is our Q. So the number of positive solutions. Sign changes. Positive to positive, that's not a change. positive to negative, that's a change. Negative to negative, that's not a change. So we only have one change. So we're going to have one positive solution. We're supposed to have how many? 3. So let's see how many negatives we're going to have. For the negative solutions, we do a negative x. The same thing we did for odd and even functions. Remember that a long time ago? So we put a negative x inside all the x's. So I changed x to negative x. So everywhere I see an x, put a negative x. The only ones we have to worry about are the odd exponents. If it's an odd exponent, that negative goes out in front. So it's negative x cubed. Negative times negative is a positive 5x down. If it's an even exponent, just get rid of that negative inside the parentheses. Nothing changes. So now, since we have a function here, let's see the sign changes. It starts off at negative, goes to positive. That's a change. Positive to positive, nope. Positive to negative. If I add these up, I get 2. So we can have 2 or 0 negative solutions. Why is it 2 or 0? Very good, yes. If we have 2 negatives and 1 positive, that takes care of our three factors. But if it's no negatives and 1 positive, the last 2 will be the special operations. So 0 is a 0. We have positive answers, negative answers, and special. By special, I mean imaginary or radicals. And we're supposed to have 3. That's the degree. So we're supposed to have 3 answers. You can only have a 0 as a 0 if all the terms have x's. Only if all terms have an x. Since we have a constant, that's not possible. All right, we worked out here, we have 1 possible positive. So that one's going to be constant. That one's 0 is going to be constant. Now, here we have 2 possibilities for negative solutions. We can either have 2 or 0. That means, okay, if it's 2, we have to add up these things. 2 plus 1 equals 3. So that means we'll have no specials. Okay. We can't have a 0. Since it's a 1, it has to stay there. So if we have no negatives, we have 1 positive, that means we're going to have 2 specials. Because 2 plus 0 plus 1 has to equal 3 if we add up 1. So those are our possibilities. So far, so good. That's just to shake the cobwebs out. So today we're going to finish the chapter. As I said, section 4 is the most difficult in the entire course. It requires the most moving parts. So now since we're over that hump, comes easy stuff. Section 5 deals with rational functions. When we say rational, we mean what? Fractions. Now, since we're dealing with fractions, our polynomials will have a numerator and denominator. Now, if you have polynomial divided by a polynomial, will it always be a polynomial as an answer? Not necessarily, right? Not necessarily. What if we had 2x plus 6 divided by x plus 3? Whenever you have equations, when you have rationals, always factor them out first. Can anything factor out of the top? A 2. They both have a 2 in common. So I'm going to take out a 2. So I took out a 2, I just have an x. And since I took out a 2, 6 divided by 2 gives me 3. And on the bottom, I have x plus 3. You can only cancel when you're multiplying. So can anything cancel? Yeah, x plus 3's. Leaving us with simply a constant. So you won't always end up with a polynomial if you divide polynomials. When you took out the 2, it became 2 times x plus 3. Then those canceled. So whenever you have an equation, always factor it out to the smallest pieces to see what cancels. And also, whenever you have an equation, top and bottom, and you have a plus or minus, always put parentheses around it because they have to stay together. In other words, I couldn't divide 3 and 6. You can't do that. So they have to stay together. So because we have polynomials, equations on top and bottom, what has to be true? What can we not have in a fraction? And you can have separate fractions if we learn how to fix those. The bottom cannot equal 0. Remember, if you have 0 on top, that equals 0. But if you have 0 on the bottom, that's undefined. And this is a no good. So we have to be very careful about what's on the bottom. That's what we call an asymptote. An asymptote is a value that makes the equation undefined. All right, so that's what an asymptote is. We have 3 different types of asymptotes. First one, it's called a vertical asymptote. Vertical asymptotes are determined by any values that make the denominator equal 0. Those are our vertical asymptotes. We have horizontal asymptotes. These are determined by the degrees of the leading terms of the numerator and the denominator. So horizontal asymptotes are determined by the degrees of the leading terms of the numerator and the denominator. And just for a refresher, the numerator is on top and denominator is on the bottom. What's that? That is a denominator. Or you said N and D.
Is it like a P?
Oh no, it's a D.
No, like the little letter. Like
This one?
X and like the bottom.
This one?
Is it a P?
It's Q.
Oh, it's a Q. Oh, I'm blind.
No, it's my handwriting. Because a Q doesn't have one straight at the bottom.
Yeah, I was like,
it's supposed to be angled to the side. They're just lazy. All right, so again, we have a vertical asymptote. That's by the denominator, the bottom number equals 0. Horizontal asymptotes, only the leading terms of the top and bottom. The third one is called an oblique asymptote. We call that the slant asymptote. Also determined by the leading terms of the numerator and denominator. Note 1. You can only have one horizontal or oblique asymptote. Note 2. You cannot have an oblique and horizontal asymptote at the same time. All right, so this defines everything we need. The easiest to find is the vertical asymptote. Let's look at that. I'm going to call VAs from now on. What's the vertical asymptote of this one? Yeah, the vertical asymptote is 0, which means the vertical asymptote is the same thing as x cannot equal 0. Now, let's look at the domain. The domain of any polynomial individually is always that of any polynomial. But once we have a fraction, we now lose that continuity. So if we can't use 0, what's our domain? We go from negative infinity to 0, and then from 0 to positive infinity. This thing, remember the parentheses mean you can't use those. How about that one? What's the vertical asymptote here? To find the vertical asymptote, take the bottom, set it equal to 0, and solve for x. So the vertical asymptote is at positive 3, which means in our answers, we cannot use 3 as an answer. So our domain goes from negative infinity all the way to 3, and then starts again from 3. But I can't use 3. The next one. X minus 3, x squared minus x minus 2. Tell me the vertical asymptote. And while we're at it, tell me the x-intercept. So we first have to factor the bottom. What signs go in there? Look at the second sign. It's negative. If it's negative, that means they're opposite signs. It's only the same sign if the second signs are positive. It's whatever the first sign is. But since it's a negative, they're opposite signs. And the bigger number, when we get the answers, the bigger number gets a negative. So that's the first thing. Forgot the signs. Now, what times what is 2? When you subtract them, you get 1. 2 times 1. 2 times 1 is 2. 2 minus 1 is 1. So the 2 gets the negative. So it goes over here, and that one goes there. Now what do you do? You factor the denominator. Now what do you do? Set them equal 0. Yeah, we have to solve the denominators. And we know from previous discussion, there's always the opposite sign of what's inside there. So the vertical asymptotes are -1 and 2. And that tells us that we cannot use -1 and -2 in our answers. What's the x-intercept? No, the x-intercept. We're doing the x-intercept, not domain. What's the x-intercept? Y3. Yes. The x-intercept only comes from the top equally 0. So x minus 3 equals 0. So x equals 3. My x-intercept is at 3, or 3 comma 0. Yeah, so whenever you're looking for the x-intercept or the zeros, always look at the top number, the top equation. So what's our domain? Very good. Negative infinity to -1. Nope. You're close. What about the numbers between -1 and 2? So from -1 to 2. And then from 2 to infinity. Let's look at this on our graph. So we have -1, and we have 2 as our. In other words, a vertical asymptote, there are lines the graph can't cross. So we can have this as a possible answer. That's from -infinity to 1. I can have these numbers, which is from -1 to 2, and I can use these. It's from 2 to infinity. All right, so whenever you have multiple vertical asymptotes, you can use it on both ends and in the middle. Okay, next one. 2x plus 5, 2x minus 6. What are my vertical asymptote? What is my vertical asymptote? And what is my x-intercept? Can you have multiple vertical asymptotes and vertical and zeros, x-intercepts? Yeah. You can have as many as the equations tell us, but you can only have one horizontal and one oblique asymptote. So to get vertical asymptote equals 3, and x-intercept is negative 5/2. Did we get that? So what are my domains? Just look at a graph. What's the only value on the x-axis I cannot use? Yeah, the vertical asymptote, I can't use it. So at 3, I can't use it. So I can't use anything there. So my domain is on both sides. Goes from negative infinity to 3. And it starts at 3 and goes to positive infinity. Because if you don't understand or if you don't get the answer, tell me instead of me just having to wait to see if anybody spits out an answer. Because if you're lost already, I need to know. So, all right, the next one. This is going to require more calculations. X squared plus 2x minus 3, x squared minus x minus 2. Same things. I want to know the vertical asymptote. I want to know what x is the x-intercepts. And I want to know the domain. So what's the first thing you got to do? Factor the top and the bottom. Second sign's a minus, so that means opposite signs. What times what is 3? When you subtract them, you get 2. 3 times 1 is 3. 3 minus 1 is 2. So the 3 gets the plus. Again, if you're lost on this, please go back to chapter 2 and review all those notes. On the bottom, x, second times a minus, so they're opposite signs. What times what is 2? When you subtract them, you get 1. 2 and 1. And the 2 gets the negative. So the vertical asymptotes are what? Negative 1 and 2. The vertical asymptotes are where the bottom equals 0. So we set x plus 1 equals 0 and x minus 2 equals 0. The vertical asymptote is where the bottom equals 0. So we cannot use negative 1 and 2 in our answers. The x-intercepts are where the top is equal to 0. So x plus 3 equals 0 and x minus 1 equals 0. So our intercepts are at negative 3 and 1. because it's the opposite of what's the signs. So looking at our graph, our vertical asymptotes are at -1. We can't use that. And 2, we can't use that. The x-intercept tells us where on the graph it's going to cross. So we know we have a point at -3 and at +1. We know the graph will cross the x-axis there. That's all we know so far. But the domains are between the asymptotes. Here are the asymptotes. So it's from -infinity to -1. It's from -1 to 2. And from 2 to infinity. That's that area, and that area. Notice, if you haven't seen this yet, you notice how it stops at that vertical asymptote and starts from it. Stops at that one and starts from it. So if we have 2 vertical asymptotes, we'll have 3 domains, 3 segments. If we only have 1, then we have, so we'll always have, you will always have 1 more domain grouping than vertical asymptotes. All right, the last one. This is how about this one? X squared minus 4x, x cubed minus x. So if we factor the top, what do we get? What do they have in common? They both have an x. There's only 2 terms, so we see what they have in common. We take out an x, what do we have left? We only took out 1 x, so we have x minus 4 left. So how about in the bottom? They both have an x. If I take out 1 x, what do I have left? So remember, whenever you factor something out, to figure out what goes in here, divide both of these by what you factored out. X cubed divided by x leaves us 2 x's left. Minus x divided by x is 1. And the bottom can be factored out even further. X squared minus 1 is the difference of two squares. So it's x plus 1, x minus 1. So my vertical asymptotes are what? Well, how many x's do you have on the bottom? You have three answers. You set all of them equal to 0. Anywhere you see an x, you set it equal to 0. So x equals 0, x equals -1, x equals 1. Again, those are where x cannot equal. How about my x-intercepts? What are my x-intercepts? Take the top, set them equal to 0. Anywhere there's an x right there. So I set it equals 0. X minus 4. So the zeros are 0 and positive 4. Because it has to be the opposite sign. But we see something here. You cannot have a vertical asymptote and an x-intercept be the same number. Because what if you look at this equation here, we can cancel out the x's. If you cancel a term, then it is no longer a vertical asymptote. It is now a whole. So what we had is this. We had x minus 4, x plus 1, x minus 1. The x's cancel. So now, all I have to do is draw, when I graph it, I only have to look at that remainder polynomial. So again, since these zeros are the same, if we put 0 in place of our x's in this equation, if we put zeros, what do you get? You get -4 divided by 1, -1. In other words, just erase the 0. So whatever the number is that you can factor out, or you can cancel, that put that number back in the equation. So we have -4 over -1. Negatives cancel, so it's 4. So at the point 0, 4, we have a whole. whole is just this. Let's say we had a graph. And at 0, 4, here's 1, 2, 3, here's a 4. Let's say our graph looked like this. At 4, I put a hole, a circle. It's still a continuous function. It's just that at that number, at 4, I have a hole. I can't use that number. It's not an asymptote, it's just not usable. All right, so that's vertical asymptote. Good question. Very good question. No, you can't use a bracket because you can't use that 0. So that's a very good question. I'm glad you asked. The domain of this one was at -1 and +1, I can't use those. So I go from -infinity to -1. From -1 to 0. From 0 to +1. And then from 1 to infinity. Because of that hole being there, I just can't use it. Now, horizontal asymptotes. HA. Remember, depends on the degrees of the leading terms. Of the numerator and denominator. All right, we have 3 possibilities here. For each of these, we're going to look at as x goes to infinity. So in this first graph, when x goes to infinity, what's it going to look like? It looks like this. The bigger x becomes, the smaller this whole number becomes. In other words, 1/10, 1/100th, 1/1000th. You see, they're getting smaller and smaller and smaller. So if you look at this graph, which direction is the graph going? Down to 0. Will it ever reach it? No, it'll get infinitely close. So whenever we have this, whenever we have more x's on the bottom, the horizontal asymptote is 0. If there's an equal number of x's in top and bottom, what's the answer? X divided by x is what? 1. They cancel. So my horizontal asymptote would be 1. It's this asymptote. Well, let's go back to the first one. Since I said the horizontal asymptote was 0, that means the horizontal deals with the y-axis. So when y is 0, that's the x-axis. The line y equals 0 is the actual x-axis. But yeah, so if you look at our graph, what it looks like, 1 over x from our library of functions looks like this. This graph gets awfully close to the x-axis, but never crosses it. So our horizontal asymptote is 0. Our vertical asymptote is also 0 because you said bottom equals 0. It never crosses this line either. So now if they're both the same, what if we had a number in front of it? Let's say 3x over 2x. What would be the answer there? 3 over 2, because the x is canceled. So if the x's are the same degree, it's just whatever's in front of it. Now, as x gets bigger, what happens to this graph? The graph of x is simply this. As x gets bigger, the y values get bigger. So it doesn't have, it doesn't have a horizontal asymptote because x over 1, as x gets bigger, it goes to infinity. All right, so I started off with this, and I'm gonna show you the rules of horizontal asymptotes. Remember, this is what our polynomials looked like. So, on top, I have x to the power n. On the bottom, I have x to the power m. So here are our 3 possibilities. Remember, the rest of this, when we look at polynomials, it's the leading term that dictates a lot. So whenever we look at polynomials, forget everything back here. We don't need, that's not important on the horizontal asymptote because the leading terms tell us everything. So we're only going to look at the leading term. Now, in our first case, if m is bigger than n, in other words, if the bottom has more x's than the top, the horizontal asymptote is 0. It's the x-axis. In the middle one, if m equals n, if the bottom equals the top, then the horizontal asymptote is simply the coefficients. And if the bottom is smaller than the top, there is no horizontal asymptote. Now, so these are our rules. We have to look at the leading terms. Look at the exponents. That's all you're comparing here. Tell me the horizontal asymptotes of these. What's my horizontal asymptote? Yep. Because there's more x's on the bottom than the top. Yeah, she just said there are more x's on the bottom. What's my horizontal asymptote here? Nope. Remember, whenever we talk about horizontal asymptotes, only look at the leading terms. Negative 7 up, nothing cancel. How about the x's? There are 4 x's there. I can cancel 4 x's there. So the horizontal asymptote is the coefficients, are the coefficients. Because same number of x's, top and bottom. What's my horizontal asymptote here? Because there's more x's on the bottom than the top. What's my horizontal asymptote for this one? Yep. Because there are more x's on top. So you're okay with horizontals and verticals so far? I mean, the rules are pretty safe. The vertical, look at the bottom, set equals 0. The horizontal, like I said earlier, just look at the leading terms. If you have more x's on the bottom, then as x gets bigger, the numbers get smaller. So close, it gets close to 0. So that's why it's 0. If there's more on the bottom, it goes to 0. If there's more on top, it goes to infinity. So there is none. And if they're the same, they cancel. Cancel the x's. Just leave the numbers alone. Yeah. So yeah, that's all you have to look for. One more. And then we'll move on. Where's the answer? Again, only look at the leading term. Who has more x's, top or bottom? The top. If the top has, it's none. But it has an oblique asymptote. Let's look at this. The last one we did before that had no horizontal asymptote and no oblique. The last one we just did had no horizontal, but it had an oblique. What's the difference between the two functions? Oh, between the last two, why does this one have an oblique and the other one doesn't? They both have no horizontals. What do you notice different about the two equations? Okay, yeah, only look at the leading terms. Always when we do the horizontals. So what about the leading terms? What's different about them? Okay, so is this one, numerator is bigger than bottom. How are they different? If the degree of the numerator is larger than the degree of the denominator, by 1, we have an oblique asymptote. In other words, for an oblique asymptote, OA, M on top or M? M on top. Remember, only look at the leading terms. If n equals m plus 1, then we have an oblique asymptote. So the last two examples we had, again, when we talk about horizontal asymptotes, I don't need the rest of this stuff. All I'm going to do is look at the leading terms. Five is much bigger than 3, more than 1. So this one has no horizontal asymptote. But in this one, now the reason why this one has no asymptote, because if you had 5 x's on top and divided by 3 x's, what do you have left? Yeah, what you have are 2 more x's on top. So as x gets bigger, this one explodes very quickly to infinity. How about here? If I have 2x's on top and I divide by 1x, I only have 1x. I now have a linear equation. Which means since I have a linear equation, I can predict because of the same step, same slope. So since n is equal to n plus 1, we can find the oblique asymptote by long division. Why is it long division? Because in our example, we could use synthetic. Why can't we use synthetic in this example? What are the conditions for synthetic? In this example, it works because the denominator is a linear equation with no coefficient. It's of the form x plus minus a number. But what if this was 2x to the 5th, x to the 4th? We couldn't use synthetic anymore. We had to use long division. So get used to using long division. All right, so let's look at this. To find the oblique asymptote, we do long division. 2x squared minus 3x plus 1. Remember how to do long division? Look at the leading terms. What times x gives me 2x squared? Well, look at the coefficient. What times 1 gives me 2? I have 2. What times x gives me x squared? 1 more x. So 2x times x gives me 2x squared. Positive times negative is a negative. 2 times 2 is 4x. Change the signs and add. The leading term cancels. 4 minus 3 is x. Bring down the 1. Now, repeat the same thing. What times x gives me x? A positive 1. 1 times x is x. 1 times negative 2 is negative 2. Change the signs. In oblique asymptotes, you don't care about the remainder. All you care about is this equation here. You only want the linear solution. It's always going to be a linear answer. Why will it always be a linear answer? 3x to the 6th over x to the 5th. Since the top is bigger than the bottom by 1, I can use oblique asymptote. But when you divide this, 1x will lay on top. Because you cancel everything but 1, you always end up with a linear equation. That's why this is called oblique. So there's our oblique. It's the oblique asymptote is this function. Oh, thank you. No. It's not 2 over 1. It's you have to use this entire equation because the oblique asymptote. Let's look at this. When we talked about asymptotes, thanks for asking the question. A vertical asymptote is a vertical line. Let's say it equals 3. So vertical asymptote is just a vertical line going up and down. A horizontal asymptote, let's say it's 2, is a horizontal line going straight across where the graph cannot cross. An oblique asymptote is a slanted line. So it has to be an equation in this 2x plus 1. Remember how our y-intercept is 1, slope is 2. So the y-intercept was 1. The slope is 2 over 1. So it's up 2 over 1. Up 2 over 1. So there's our, and it has to go through that y-intercept. And you can have a vertical, you can only have one of these. You can either have a horizontal with a vertical or a horizontal or a vertical with a oblique asymptote. You can only have one or the other with a vertical asymptote. Let's see. Have any examples for that one? Yeah, that was the only one. Okay. So that's how you find the asymptotes. Reason we need those is because if you think about what we have so far, we have X-intercepts. We have the Y-intercept. We know the degree. That's whether it's going to be like this, like this, like this, or like this. The degree tells us the shape of the curve. Our leading coefficient tells us the direction, whether it's increasing, decreasing, increasing, decreasing. If the degree is odd, it looks like this. If the degree is even, it looks like this. If A is positive, if A is negative, A is positive, A is negative. Remember, we had that chart. We did that chart. Huh?
But that's still apply to, like, since it's 2x plus 1 and it's a odd, because of the 1.
Oh, no, actually, whenever you have a radical fraction, 2 polynomials, it changes the shape of the curve. Because I'm glad you asked that. This worked whenever we had regular polynomials. But once you have rational polynomials, because of these asymptotes, we now change our entire graph. And I'll show you pictures of those in a second. So if a is positive and it's an odd function, they go opposite direction and it goes to the right up. If a is negative and it's an odd function, it goes down. If a is positive and it's even, both endpoints go up. If a is negative, both endpoints go down. So that's what we know so far. So we know the x-intercepts, the y-intercepts, the degree, the a, the vertical asymptotes, the horizontal asymptotes, or oblique asymptotes. We can factor to find the zeros, which are the x-intercepts, the number of positive, negatives, or specials. I mean, we can do all this stuff to help define what the graph looks like. I mean, we can have equations where it has an asymptote here, and another asymptote, a horizontal asymptote. Can't have both of those, sorry. You can't have a horizontal and a vertical. A vertical and a slant. The graph here would look something like this. Where you have the vertical asymptote and an oblique asymptote. And the graph simply fits there. So it changes the shape of a graph. When we first started, our graphs can look like this, but now they can change depending on what the oblique asymptote does, if we have one. And I'll show you pictures of those in a little bit. Let's finish up the chapter, and then I'll show you these pictures. Well, actually, not sure. Let's switch over to the computer. Okay. With what we know so far, look at this function. Remember what the graph looked like? That's with what we talked about today. What's a horizontal or a vertical asymptote is what? Vertical asymptote is where the bottom is equal to 0. So it's 0. Is there a horizontal asymptote? Yes, there is. There's more x's on the bottom. So the horizontal asymptote is 0. Here's the graph. The horizontal asymptote is 0, is the x-axis, and the vertical asymptote is 0, which is the y-axis. Let's look at the next one. 1 over x squared. Do we have a vertical asymptote? Yes. Set the bottom equals 0. X squared equals 0. X is 0. So we know at x equals 0, it's an asymptote, which is the y-axis. Is there a vertical asymptote? I'm a horizontal asymptote. Where? It's since there are more x's on the bottom, it's 0. The y-axis, the horizontal asymptote is still y equals 0, which is the x-axis. This graph looks like this. It can't cross the x equals 0 vertical line. It can't cross the y equals 0, the horizontal asymptote. It never crosses it. How about this one? X minus 3, x squared plus x minus 2. Since we have a polynomial on the bottom that's quadratic, we can try to factor it out. So tell me the horizontal and vertical or oblique asymptotes. The vertical asymptote? No, the vertical asymptote. Yes. Yes, the horizontal asymptote will be 0 because there's more x's on the bottom. So let's do that. The horizontal asymptote is 0 because there's more x's on the bottom. The vertical asymptote is we have to now take our denominator, factor it out, which gives us x plus 2, x minus 1. So our vertical asymptotes are at -2 and +1. Yeah, so the horizontal asymptote, since there are more x's on the bottom, we know that the horizontal asymptote is 0. The vertical asymptote, we factor out the bottom, set them equals 0. Now, what's the graph going to look like? It's going to have 2 vertical lines and 1 horizontal line. Now, since x squares on the bottom, our major graph will look like the x squares on, they go on the same sides. Remember our vertical asymptotes were -2 and 1. At -2, we have a vertical asymptote. And at 1, we have an asymptote. And the graphs will not cross those lines. Our last asymptote was the horizontal one. It's not going to cross this one. And so what we have to do is, since we know where the asymptotes are, can't cross the lines, we just plot some points. Since this is a vertical asymptote, from the left side, the graph's either going to come up here and not touch it, or if it's on the bottom, it goes down here. We just plot some points and know what the graph's going to look like. How about that one? The vertical asymptote, the horizontal asymptote, or oblique asymptote. What is? HA is no. Oh, yeah, it's 1. I'm sorry, I was thinking wrong number. Yes, because of horizontal asymptote, we have 2x over 2x. They cancel, so it's 1. The horizontal asymptote is a horizontal line at y equals 1. The horizontal asymptote is a horizontal line crossing the y-axis at 1. Yeah, so we know the horizontal asymptote is 1. Because we had 2x over 2x equals 1. The line at y equals 1. The vertical asymptote is 2x minus 6 equals 0. So x equals x or 6 divided by 2, which is 3. All you do is take the bottom equation, set it equal to 0. Let's look at the graph. The horizontal asymptote was at 1. Line's not going to cross that. And the vertical asymptote was at 3. So the graphs. So again, to figure out where it's going to, where the graph's going to be, just plot some points. At 0, what is it? Or at 4, what is it? Then you'll see a basic shape forming. Yeah, this will be the last one. And then we'll move on. What's the first thing you're going to do? Right, you're going to factor it. Factor both the top and the bottom. We know the horizontal asymptote is going to be what? 1, because the top and bottom have the same exponent or same degree, and there's no coefficient. So the horizontal asymptote is 1. The vertical asymptote is where? Oops. The vertical asymptote. We take the bottom, set it equal to 0, and factor. We get x minus 2, x plus 1, because I have to have opposite signs. Solving them, we see we get positive 2, negative 1 as our vertical asymptotes. And we know the horizontal asymptote is 1. Again, plot some points and see that this is what the graph's going to look like. We have intercepts at positive 2 and negative 1. So negative 1 is here. Positive 2 is here. And a horizontal asymptote is at 1. So we see the outer graphs fit perfectly around the asymptotes. But the middle part something has to happen there. So we know the x-intercept is going to be at 3/2, which is 1 1/2. And we just plot some points and we see a graph forming this way. The middle part's going to be the most difficult. It can either be a U above the horizontal line or below the horizontal asymptote, or it can cross like this. It is possible, these are the exceptions to the rule, that a graph can cross the asymptote. The horizontal asymptote, not the vertical. All right, so let's go back now and let's finish up chapter 4.
Section 5 is the last one.
Section 6 is. Section 6 is even easier. It's inequalities. And the concept of inequalities. I know every time I say something, it's another section, another section, another section. This is the last section of chapter 4. We have polynomial inequalities. And then later we're going to do rational inequalities. We're going to do these two today. Solving polynomial inequalities. We've done that already. We instead of inequalities, we had equal signs. So first step is solve as if we had an equal sign. Let's see here. So we have x squared plus 3x minus 5 is less than equal to x plus 3. Don't worry about what this says. Don't worry about the inequality. Treat it like an equal sign. Move everything to the larger exponent. Fortunately, the larger exponent is to the left side, so we move everything to the left. We subtract x, and we subtract 3 from both sides. So those are gone. We have to have a 0 on one side. It has to, like polynomials, have to equal 0. Positive 3 minus 1 is positive 2x. Negative 5, negative 3 is negative 8. So that's the first step. Set equal to 0. Second step is factor. X and x. What is the second sign being minus? It tells us what? Different signs. Very good. What times what is 8? When you subtract them, you get 2. 4 times 2. 4 times 2 is 8. 4 minus 2 is 2. So the bigger number gets the plus. So 4 goes there, 2 goes there. Solve. So in other words, we set both of these equations equal to 0. the solutions are called the critical values, or the CV. The reason they're called the critical values is because what's another name for them here? When we do this, what do these represent to us? Yeah, they're the zeros, they're the X-intercepts. So we know we have it at -4, we have an X-intercept. And at 2, we have an X-intercept. The reason they're critical is because they'll tell us where the answers are. Now, from earlier, we know what, looking at this equation here, we know the equation is x squared plus 2x minus 8. What do we know by looking at this equation? The degree is 2, so, and it's positive, so we know the graph's going to look like this. We have a y-intercept at 8, -8. So we know the graph will look something like this. We knew that. Now, knowing that from earlier, what the graph looks like, and now we have the x-intercepts, the only thing that we have to do here is determine if you want the part or parts of the graph that are above or below the x-axis. Because now once you factor it out, get the x-intercepts and sketch the basic graph, that's what we've been doing all along. All we want to know is above or below. Where does that come from? Since our equation was this less than equal to 0, less than or equal to 0. So what does that tell us? What part of the graph do we want? Above or below the x-axis? Now look at this. I want the answer, the equation is less than 0. Yeah, this says I want it to be below. So this is the only part of the graph I'm interested in. And the domain there, the answer there is from -4 to 2. And since I have equal, I could use those. That's my answer. With inequalities, we're looking for more than just one number. We're looking for a series of numbers. That's why we have to use the inequality, the domains. And since if our equation is less than 0, it's below the x-axis. If it's greater than 0, it's above the x-axis. Let's look at another one. X cubed minus x is greater than 0. So we got 0 on one side, so we just factor. we can take out an X. Remember, whenever you factor, they both have an X, or take out an X. If I divide both of those by X, I see what goes inside the parentheses. I can factor that one further. X plus 1, X minus 1. So what are my critical values? What does this one give you? Anywhere you see an X, you have to have 3 answers. So the first one is X equals 0. So it's the answer, critical value is 0. -1, +1. You're not the only one. A lot of people forget about this X out there in front. It's a factor. I don't need it. No, it's an X. It contributes to everything. Now, if you don't remember that this is the difference of 2 squares, when we set them equal to 0, you just go ahead and solve that one. So X equals plus or minus square root of 1 is 1, which is what we got there. So looking at our graph, we have an X-intercept at 0, at -1, and at +1. And since that's also the Y-intercept. What's the degree of our equation? And what's our A? A is in front of the X, the large, it's the leading coefficient. It's 1. It can't be 0. If it was 0, then this would be, the whole thing would be 0. Oh, no. So the A is 1. Since A is positive and the degree is 3, we know our graph will look something like this. From the left endpoint, our graph will go down. The right endpoint, the graph will go up. Because the multiplicities are all 1, they all cross. You see how we're putting everything we've been discussing and putting it, so we start putting it all together, it builds it for us. And what I'm looking for is this. Greater than 0. Is it above or below? Above, yeah. I want only positives. Greater than 0. That's here and here. Can I use the endpoints? No, because there's no equal sign. So my solution is from -1 to 0, and from 1 to positive infinity. That's my solution. So far, so good. That's polynomial inequalities. It's the same stuff we've been doing. Once we draw a graph, we either want above if our equation is greater than 0, below if our equation is less than 0. And just tell me the intervals of where it's above or below. That's all I want. And if we had more time, I'd give you something like this. This question alone would be a perfect test question for this chapter because it does everything we just talked about. The first thing you have to do, since this is a 4x3, everything's gonna move to the left. I subtract 11x cubed and a 4. So nothing combines there, so it's just 3x to the 4th minus 11x cubed plus 10x minus 4. So are we looking for stuff above or below the x-axis? Below, because it's less than, right? Because it's less than, I want below it. Now, what we have to do is figure out how many positives, how many negatives. Then we have to do the P over Q. We have to go through all of that, which is everything. This is everything in one question. You have to first find the possible zeros. 1, 2, 4, 1, and 3. And we're not going to work it out, but this will set it up. We'll look at positive negative 1 over 1, positive negative 2 over 1, positive negative 4 over 1, 1 over 3, 2 over 3, 4 over 3. So these are find our critical values. And how would you check it from there? Well, yeah, that's to tell me how many positive and negatives. First look at, so we're going to have this 1, 2, 3 or 1 positive answers. Yeah, that just tells us how many answers we're positive or negative we're going to have. But in order to find our critical values, we'd have to do synthetic division with positive 1, negative 1, positive 2, negative 2, positive 3, negative 3, so on and so forth, or these. Yeah, what we just did here, the signs, the Descartes rule of signs tells us how many positives or negatives we're going to have. But to find the actual ones, we have to do synthetic division. But yeah, that would just take us too much time. We actually did that a long time ago. The last thing, the very last thing, are rational inequalities. Rationals are fractions. So the same rules. Set equal to 0. Simplify the equations. But now you have to look for horizontal asymptotes, vertical asymptotes, or oblique asymptotes. So what we're going to end up with, we have 2 polynomials. If you set the top equal 0, what does that give you? What does that find for you? That finds the x-intercepts. If you set the top equals 0, you get the y-intercepts. If you set the bottom equals 0, that finds the where it's undefined, finds the vertical asymptotes. So it has 0 to one side. Another difference here is this. What are my x-intercepts? Set the top equals 0, x equals 0. The bottom, we have x plus 6 equals x equals -6. That's my vertical asymptote. This is my x-intercept. Both of these are critical values. They're both important. So at 0, and -6. So that's a vertical asymptote, so we can't use that at all. Okay, what's the horizontal asymptote? Remember, only look at the leading terms. So we have 3x over x. What happens with the x's? They cancel. So at 3, we have a horizontal asymptote. So let's look at this. At -3, if I plug in -3 in this equation, what do I get? 3 times -3 over -3 plus 6. -9 over 3 is -3. If I put +3 in there, so 3 times 3 over 3 plus 6, 9 over 9 is 1. Since I know my asymptotes are there, the graph will look something like this on that side. Now, how about if I can't use that one? How about if I use -9? 3, -9, -9 plus 6, -27 over -3, negatives cancel. So 27 over 3 is 9. So at -9, it's 9. So I know over here then, my graph will look something like this. So far, so good. That's how I drew the graph. But I only want the part of the graph that's below 0. That's everything here from -6 to 0. That's my answer. x plus 1, 2x minus 4, less than equal to 1. What's my first step? Is it 0? Nope. I have to subtract 1 from both sides. So x plus 1, 2x minus 4, minus 1 is less than equal to 0. I have to combine these two equations. So we have to have a common denominator. So that means the common denominator is 2x minus 4. 2x minus 4. Since 2x minus 4 over 2x minus 4 equals 1, makes it easier for me. I have a common denominator, so I'll just write it down once. And now on the top, I put what I have left. So on the top, including the sign. Let's see about the parentheses. Do you need the first pair of parentheses? Is there a coefficient? No. This negative changes both of those signs. So it's negative 2x, positive 4. Now combine like terms. Negative 2x plus 1x is negative x. 4 plus 1 is 5. We have to set both the top and the bottom equal to 0. So the top's going to say x equals 5, because I add x to both sides. X equals 5. Add 4, then divide by 2, x equals 2. So my critical values are x equals 5 and x equals 2. The 2 on the bottom is our critical value. I can't use that. That's my vertical asymptote. The 5 is my 0. That's my y-intercept or x-intercept. What's my horizontal asymptote? Just look at the leading terms. Negative x over 2x. Equals what? Negative 1 over 2. That line has to stay there. The x is below the line. It can't come on top. The 2 is below the. So all that cancels is the x's. And there's a 1 in front of it. So it's at negative 1/2. So looking at this equation, let's try to graph it. I can't use 2. We know that's a 0. So if I put a 3 in there, -3 plus 5. So -3 plus 5 is 2. 2 times 3 is 6, minus 4 is 2, so it's 1. So it's that. So at 3, it's 1. And so I know my graph's gonna look like this. Since I only have 2 quadrants. And I'm guessing on this side, it's gonna be down here also, but you can just plot some points and see. So I want what's below the x-axis. So from here, it has to be, let's look at this side. Oh, the whole thing's below the x-axis. There's the x-axis. So from -infinity to 2, that's part of my answer. Now, how about this side? Which part is below the x-axis on this other graph? Here's the x-axis, all this stuff. Starting at 5 to infinity. But can I use that 5? It's less than equal to 0, so I can use that 5. And it's a union between there. Making sense? But yeah, I mean, it'll be a video, so we'll watch it later on. And the last one we're going to do. X minus 3, x plus 4, x plus 2, x minus 5. Again, we have to have a 0 on one side. So let's move this whole equation over there. How do we do that? Yeah, just subtract the whole thing. Minus x plus 2, x minus 5 is greater than equal to 0. Okay, now since we have different denominators, we have to get a common denominator. X minus 5. So this one's, I have to multiply x minus 5 over x minus 5. And this one's missing an x plus 4. So it's x plus 4, x plus 4. X plus 4, x minus 5 is the common denominator. And here I have x minus 5 times x minus 3 minus x plus 2 times x plus 4. Leave the bottom the way it is. Since it's factored, it's perfect. Because we know the 2 vertical asymptotes already. So we know the vertical asymptotes already are -4 and +5. All we have to do is fix the top. The way we do that, we have to multiply them out. So in this first equation, X times X is X squared. Positive, negative is a negative, 3X. Negative, positive is negative 5X. Negative, negative is a positive. 5 times 3 is 15. Same thing on the other side. X squared, positive 4X, positive 2X, positive 8. Again, you shouldn't have to be looking at the screen all the time. You should know how to do this already. We've done hundreds of them already. You shouldn't have to copy off my screen all the time. You need to practice these. X plus 4, X minus 5 on the bottom. Combine like terms inside the brackets. So we have X squared minus 8X plus 15 minus X squared plus 6X plus 8. We don't need the first brackets. There's nothing, no coefficient. So it's X squared minus 8X plus 15. That negative in front of the second one changes all the signs. So it's minus X squared, minus 6X, minus 8. Greater than, equal to 0. X squareds cancel. Negative 8X minus 6X is negative 14X. 15 minus 8 is positive 7. X plus 4, X minus 5. Negative 14X plus 7. X plus 4, X minus 5 greater than equal to 0. Now we can factor out the top also. Take out the negative, and they both have a 7 in common. 2X minus 1. Remember, since it's a negative in front, I have to factor out the negative. And since they both have a 7. So to figure out what goes inside the parentheses, since I factored out a negative 7, I divide both of those by negative 7. Negative cancels. 7 over 14 divided by 7 is 2X. Positive negative is a negative. 7's cancel, so it's a 1. My critical values. My 0, or the X-intercept, is at 2X minus 1 equals 0. X equals 1/2. So that's my X-intercept. The vertical asymptotes are at -4 and 5. So there's X cannot equal those. Those are vertical asymptotes. What's my horizontal asymptote? Yep, because there's more X's. It's X squared on the bottom, X on top. Do we want above or below the x-axis? Yeah, since this is greater than 0, I want above. So let's sketch the graph. The horizontal asymptote is the x-axis. My vertical asymptotes are at -4 and 5. So let's look at this. If I put in a 6, 2 times 6 minus 1, 6 plus 4, 6 minus 5. -7 times 12 minus 1 times 11. 10 times 1, -77 over 10. That's -7.7. So at 6, my graph is down here, so it looks like this. I just picked it because I can't use those. I just have to see what the graph is. So I take a number I can. I took for 6. I could have taken 10 or 20, anything on that side. Plug it in there. I just want to see if it's above or below. Because since it's above or below, I know it's going to have that shape. Same thing over here. Since I can't use -4, I just take -5. Plug it in the equation. This equation. -7, 2 times -5 minus 1. -5 plus 4, -5 minus 5. So it's -10 minus 1, -1, -10, -11, over 10. So it's +77 over 10, which is just the opposite shape, opposite side. So it's like this. Now in the middle, let's plug in some points. Let's put 1, 0, and -1 in there. See what happens. -7, 2 times -1 minus 1. -1 plus 4, -1 minus 5. Then we do the same thing with 0. 2 times 0. Then we do +1. And work them out. -7, -2 minus 1. -1 plus 4 is 3. -6. -2 minus 1 is -3. -3 times 7 is +21 over -18. They both have a 3 in common. So it's -7/6. So at -1, it's -7/6. It's just over 1. It's there. At 0, what are we at? That's +7 over -20. It's still in the negatives, so it's going to be closer to 0. So it's 1 times it's -7. 5 times 4 is -20. So it's +7 over 20. So this side is going to look like this. our solutions, we want to be greater than above the x-axis. From negative infinity to negative 4. Well, if I put in 0, it's 7 over negative 20. It's 1. Oh, okay, yeah. The y-intercept then would be 1/2. Yeah, so the y-intercept is 1, or the x-intercept is 1/2. I took the top, set equal to 0. Negative 14x plus 7. Subtract 7. Negative 14x equals negative 7. Divide by negative 14. X equals 1/2. So that's right. So I went above the x-axis. So I went from 1/2 to my next. Since it's equal to 0, I can use that. And that's my answer. The rest of the graph is below. And these are the only parts of the graph I want above the x-axis. But I can use the x-intercept. All right, that about covers it. That's all of chapter 4. Yes, it is cumbersome. But from here on out, it's straightforward, just numbers. Because in chapter 5, we're going to deal with exponentials and logarithmics. Chapter 6 will be systems of equations. That's like we have 2x plus 3y equals 7, 4x minus 2y equals 5. You have two separate graphs, and where they meet is your solution. I'm going to show you a shortcut for that one. So I'm also going to modify the homeworks also. So on the exponents and logs, I'm going to jump straight to the shortcuts. So we'll do this next Monday. Now I want you guys to try. Well, crap, I'm asking a lot from y'all. But we also have the week after Thanksgiving as more work days. Because I'm not going to cover anything new after next week. So it'll give us one free week to do anything we want. So I'm going to, use the videos, try to do as much as you can in chapter 4, because next week we're going to do 5 and 6 really quick. And they're a lot easier. So I'm going to cut off chapter 7 and 8 from the class from the final. 7 and 8. Because there's no way we can get that far in a week. We're going to be pushing it for chapters 5 and 6. So, but we'll definitely, for sure, we'll do chapter 6. Because there's a shortcut I'll show you for that one. And then chapter 5, I'm going to touch the highlights of it. And cut off a whole bunch of homeworks. All right? So, if there aren't any questions, have a great, safe weekend.